We will be discussing triangle similarity theorems and corollary. Now, these are the following. We have the angle-angle corollary, the angle-angle-angle similarity theorem, or the AAA similarity theorem, the SSS similarity theorem, or the side-side-side similarity theorem, and the side-angle-side similarity theorem, or the SAS similarity theorem. And these three theorems and one corollary can be used to determine if the given triangles or pair of triangles are similar or not. All right. And we will be choosing which of the four of the theorems or corollary are the best way to describe that the two triangles are similar or not. So let's continue with this similarity. Now, let's discuss about the angle-angle similarity theorem first. Now, it says here, according to Moyes and Downs, given a correspondence between two triangles, so there must be a correspondence between two triangles. So let me just change my pen. Okay, there must be correspondence between two triangles. And if the corresponding angles are congruent, then the correspondence is a similarity. So which means if we have identified that the corresponding angles, the three angles of the triangles, are congruent to another three angles in the other triangle, then we could say that these two triangles are similar. All right. So let's use this figure to illustrate the angle-angle similarity theorem. So if we're going to observe the two figures, they have the same shape. These two triangles have the same shape. And we could say that, let's assume that angle A corresponds to angle D. And let's say they are congruent, okay? And also, let's say that angle B corresponds to angle E, and let's say that they are congruent. And lastly, let's say angle C corresponds to angle F, all right? And also, let's say that they are congruent. So all three angles of the triangle in triangle ABC, okay, are congruent to their corresponding angles on the other triangle, which is the triangle BEF. All right. So in this case, we could say that these two triangles are congruent by AAA similarity theorem. So we could say that triangle ABC is similar to triangle. Of course, we need to write the other triangle according to its corresponding sides or angles from the given triangle ABC. So we have A corresponds to D, so therefore this is D, and B corresponds to E, therefore this is E, and C corresponds to F, so therefore this must be F. So we could say that triangle ABC is similar to triangle DEF, all right? Or by virtue of angle-angle-angle or AAA similarity theorem. Okay, and let's proceed to the next. All right, now we have angle-angle corollary. Now it says here, given a correspondence between two triangles. So again, there is a correspondence between two triangles. The correspondence is very important when it comes to similarity of triangles, as well as with congruent triangles. Now, if two pairs of corresponding angles, again, only two pairs of corresponding angles are congruent, then the correspondence is a similarity. All right. So a while ago, we need three corresponding angles, which are congruent, okay, for us to say that the two triangles are congruent. But in this corollary, now we only need two. We only need two angles, two corresponding angles on both triangles for us to conclude that these two triangles are congruent. All right. So now let's illustrate this corollary, okay, using this figure. So let's say angle A corresponds to angle D and B corresponds to angle E. So let's assume that A is congruent to D, okay, and angle B is congruent to angle E. So these are the two angles, okay, two angles, corresponding angles which are congruent. And according to a corollary or the angle-angle corollary, now as long as we have identified two corresponding angles to be congruent on both triangles, then we could say that these two triangles are similar. Okay, so which means that I can conclude that triangle ABC is similar to triangle DEF. Again, please observe the corresponding parts in writing the similarity statement. So here, again, we have only two angles okay? We have only two angles needed for us to determine that these two triangles are already or are similar, right? So we can use the angle-angle if you want, and we can also use the angle-angle corollary, okay? So these are the two theorem and corollary for similarity of triangles that can be used. All right. Now let's proceed to the next theorem. We have the SAS similarity theorem. Now the SAS sounds like familiar because we've been using SAS for proving that the two triangles are congruent. All right, and we can also use SAS for proving that the two triangles are similar. However, let's find out what's the difference between SAS in congruence and in similarity. Okay, so let's read. Now, given a correspondence between two triangles, again, there is a correspondence. Okay, there are corresponding sides and angles between the two triangles. Now, if two pairs of corresponding sides are proportional, again, they should be proportional. The corresponding sides, two pairs of corresponding sides are proportional, and their included angles are congruent. Then the correspondence is a similarity. So which means once we identify that the two pairs of corresponding sides of both triangles are proportional, which means that their ratios are, the ratios of the corresponding sides are equal, all right, then, and then their included angles are congruent, then we could say that the two triangles are similar. So how do we illustrate that here in this triangle? So we have, let's say, okay, now let's say AB, okay, AB corresponds to DE, okay? And let's say this is our A, and this is our B, all right? And also, let's say BC, okay, corresponds to EF. And let's say this is our C, and this is our D. Okay, so we have already identified the two pairs of corresponding parts. And based on the given, these corresponding sides must be proportional. So when we say proportional, if I'm going to make a ratio of the corresponding sides, which are A over B and C over D, all right, A is to B and C is to D, then they should be proportional. Or their ratios, the values of their ratios should be equal, all right? And of course, there must be the word and. Don't forget the word and. They're included angles. These angles, the angle B and the angle E, must be congruent. So if these angles B and E are congruent, then we could say that these two triangles are similar. So by virtue of the sides to be proportional and the included angle to be congruent, then these two triangles are congruent. So since we have identified the proportional parts, okay, and the congruent angles, which are the included angles of the two corresponding sides, then we could say that triangle ABC is similar to triangle DEF. All right, and this is by virtue of the side angle side. Now, what's the difference of SAS similarity theorem with the SAS with the congruence postulate? Now, the difference is for similarity theorem, SAS, under sides, the sides must be proportional. However, for congruence of triangles, the sides must be congruent. Okay, so under congruence of triangles, the sides should be congruent, but for similar triangles, the sides must be proportional, or the corresponding sides must be proportional. So that's the difference between the two. Okay, and I hope it's clear. Now let's proceed to the next, the SAS similarity theorem. Okay, now here, the SAS similarity theorem. Okay, now let me just, oh, we have two. Okay, I think there's something wrong here. Now let's read this one. Given a correspondence between two triangles, if corresponding sides are proportional, then the correspondence is a similarity. So here, there's something wrong here. It should be, okay, it should be SSS, since we have already discussed the SAS, SSS. So by the definition, by the theorem itself, let me underline. Okay, let's use yellow. So again, there must be a correspondence between two triangles. The correspondence is very important here, okay? So you should have a correct way of finding the corresponding parts, or else you will be mistaken, okay, in solving the triangles. So here, if the corresponding sides, it's not stated 1, 2, or 3, and by the statement itself, there must be 3 sides, all right? Because there are 3 sides in a given triangle. So are proportional. So the 3 sides should be proportional, all right? Then the correspondence is a similarity. So here, let's identify that, let's say AB corresponds to DE or ED. Okay, let's say this is A and this is B. And let's use another color of pen. Let's say green. And BC corresponds to EF. Okay, whatever corresponding sides you identified, as long as you will end up at proportional sides or proportional corresponding sides, then that would be okay. That's fine. Okay, and let's say this is C, this is our D, and of course the last. Oh, sorry. Let's use another color. Blue. All right. So AC and DF. And let's say this is ABCD, this is E, and this is our F. All right. So we have already identified the corresponding parts, AB. So let's make a ratio. Okay, using the corresponding parts, A over B. Next, C over D. Next, we have E over F. And if we identified, all right, or if we determined that these ratios, the 3 ratios are equal, okay, and we can say that they are proportional, therefore, these 2 triangles are similar. Again, by the SSS similarity theorem, it says here, now given a correspondence between 2 triangles, if corresponding sides are proportional, okay, so they are already proportional, the ratios are equal or congruent, then the correspondence is a similarity. So therefore, we could say that triangle ABC is similar to triangle DEF based on our set or assumed correspondence. Okay, so this is how we use the similarities theorems, the SSS, the SAS, the angle theorem, and the angle corollary. All right, and okay, here we go. So let's apply these four theorems and corollary to determine if the two triangles are equal or not. Sorry, are similar or not. And these examples were adopted from the kotasoftware.com. All right, and you can visit them if you want. There are lots of examples. Take a look at number one. So here, state if the given triangles are similar or not. If they are, and let me just underline, state if similar or not. And if they are, state the reason. What reason? The theorems and corollary, the AAA theorem, AA corollary, and the two theorems, the SSS and the SAS, and complete the similarity statement, this one. All right, so let's move on. So here we have two sides given, okay? Two sides for this triangle and two sides for another triangle. So which means that this could be SAS or SSS or SAS since two sides were given. Okay, we're not so sure yet, but let's verify. Okay, and we need to identify the corresponding parts because the correspondence must be present for us to identify the corresponding parts, of course, plus the ratio, okay? And if the ratios are proportional or equal or not. Okay, so let's identify here. Okay, if we're going to, look at this, guys. Now, the sides of the triangle here, the DUE, the sides are equal, okay? However, on the other triangle, the SUT, the sides are not congruent or equal, okay? So therefore, we could somehow, okay, let me just change the color of the pen. Okay, here we go. Oh, let's use yellow. Yellow. Okay, here we go. So I could say, wait a minute. Okay, so we could associate the correspondence. I mean, we could use 39 and, okay, 16 here, okay, to be the corresponding parts, and 40 to be the corresponding parts to 16. So I could say 30, oops, oh, sorry. Okay, so let's continue. We have 39 over 16, and the other ratio is 40 over 16. Okay, so these are our correspondence, okay? I mean, yeah, corresponding sides or corresponding parts. And look at this, guys. This angle and this angle are congruent because they're vertical. So therefore, we can use the SAS, okay? And since there are no other sides given, or the third side, the length of the third sides were not given, so therefore we cannot use the SSS, okay? So we're looking into the SAS here. So the angles are already congruent, so therefore checked. All right, the A is already checked. Okay, let's identify if they are proportional. Now in this case, 39 over 16 and 40 over 16. Since the denominators are equal and the numerators are not equal, therefore these ratios are not equal. So therefore, we could say that they are not proportional, okay? They're not proportional because the ratios are not equal. So therefore, we can say that SAS does not apply here because there are no, or there's no proportionality in the given corresponding sides of the two triangles, all right? So we could say that these two triangles are not similar. They're not similar, okay? This is not, these two triangles are not similar. Now, you might think of the corresponding sides might be misrepresented misrepresented or mispaired, okay? All right. So you might incorrectly paired the corresponding sides. That's why you were not able to get the proportional sides or equal ratios. Okay, so let's try to switch the pairing or the corresponding sides here. So instead of pairing 39 to 16, let's pair 39 to another side, which is 16, and 40 over 16. But still, since they're both 16, therefore, they will still be not equal, right? Or they're not proportional. So therefore, we could say that the SAS does not really help us to determine that these two triangles are similar, okay? So again, we could say that these two triangles are not similar, okay? So number one is not similar. Okay, number two. In number two, let's identify. Okay, let me change the color. Let's use blue. Okay, or yeah, blue. Okay, so here we have two triangles and three sides were given. Three sides were given. So at this moment, we're analyzing the given in the triangles. Okay, so again, the sides, three sides were given and three sides were given. So therefore, we could use the SSS or the SAS here. All right, since there are sides. However, there are no angles given, so therefore we could cross this out. So we are focusing on the SSS similarity theorem. So here, let's identify the corresponding parts. So by using the shape of the triangle, the shapes of the triangles, so I could say that aside from the shape, we could use that the we could use the sides of the triangle itself. Okay, let's identify the largest or the longest. Okay, the longest sides. So these are the longest sides. So we can pair that up. So it means that they are the corresponding sides here. So 84 over 14. And let's move on to the shortest. The shortest and the shortest. All right. Yeah, here we go. So we have 48 over 8. And here, of course, the two sides of the two triangles, okay? I mean, one side of the triangle could be paired to the other side of the triangle, which are the left, I mean, the middle, right? The short. Okay, it's not the shortest. Okay, so we have 72 over 12. Okay, so we are always starting from the larger triangle. But if you started from the smaller, you can also do that, okay? You can also use the smaller triangle to be the numerator and the larger one to be on the denominator. Okay, so let's identify if these ratios will give us an equal ratio, or let's determine if they are proportional. So let me just use white. Okay, so let's simplify this. If we're going to simplify this, this is equal to what? So this is by 7, right? So this is 12. Am I correct? 84, 7, yeah, 12. And this is 2, so this becomes 6. Okay. Oh, 6 is to 1. And this one is equal to 6 is to 1. And this one is equal to 6 is to 1. Oh, so we got equal ratios. So therefore, the ratios of the corresponding sides are equal, and the ratios are proportional, okay? Or the sides are proportional of these triangles. Since we have already identified that the corresponding sides of the two triangles are proportional, then we could say that these two triangles are similar by SSS similarity theorem. Okay, so again, this is correct. So how do we do it? How do we write the statement, the similarity statement here? So we could say, oh, let me change the color of my pen. Okay, let's use red. All right, so we have triangle. Okay, C is here, and okay, the corresponding side is 72, and I mean the opposite side is 72, and 72 is paired with 14, so therefore its opposite angle is G. So therefore G. Okay, and angle B is here, and its opposite side is the longest side. So therefore the longest side here, oh, sorry, I think I'm wrong. Okay, let me just erase. Oh, I got wrong here. Okay, so let's correct that one. Okay, it's red. Here we go. So again, C, the corresponding angle of C is, okay, there we go. 72, the opposite side of angle C is 72, and 72 corresponds with 12, sorry, with 12, and the opposite angle of 12 is F, therefore this is F, okay? And angle B's opposite side is the longest side, and the longest side here and the other triangle is 14, and its opposite angle is G. Therefore, it's G. And A, of course, there's no other side or other vertex or angle, so that's H. So therefore, since these two triangles are similar, therefore we could say that the similarity statement is triangle CBA is similar to triangle FGH using or by virtue of the SSS similarity theorem or the side-side-side similarity theorem. Okay, and I hope it's clear. And let's move on to the next example. Okay, try to answer the problems by pausing the video and check whether you'll get the same answer as mine. All right, so let's move on to number 3. Here, let's identify again if these two triangles are similar or not. Now, there are two sides given, okay, 14, 8, 49, and 28. And there are two angles which are congruent because they're vertical, correct? So, oh, we could use the SAS or the SSS since there are two sides. Two sides, two sides. However, we already spotted an angle, a congruent or congruent angle. So therefore, we're not going to use the SSS anymore. We could use the SAS, okay? So let's check whether the corresponding sides are proportional. So here, 14 is greater than 8. Therefore, our correspondence will be the longer side here as well, which is 49. So we could say 14 over 49. And the other side is, I mean, the other corresponding sides are 14. So we'll start from 8 over 28. Okay, here we go. So we already identified the ratios, and let's simplify if these two ratios are equal. Okay, so we have by 7, so 2 over 7, by 4, this is 2 over 7. Oh, so the ratios are equal, and we have proportional sides in a given triangle. Okay, and since these angles are included angle of the two sides, so therefore we could say that the SAS, okay, SAS can be used to show that these two triangles are similar. So therefore, the two triangles are similar. And how do we write the statement, the similarity statement? So again, we're going to find the corresponding parts, especially the angles or vertices. So VUT, okay, of course, V to V, because they're congruent. And U is here, and U, the opposite side of U is the longest side, or the longer side, I mean. And okay, the longer side is here, and its opposite angle is angle L. So VL, and there's no other vertex because there are only 3 vertices in a given triangle. So that's VLM. So the similarity statement is triangle VUT is similar to triangle VLM. All right, so that's how we do it. Okay, so let's proceed to example number 4. Again, you can pause the video and try to answer this. And let's check if we'll have the same answer. So let's identify. In number 4, oh, there are labels, markings. Now we have, is this red? Oh, let's use another color. All right, to distinguish this, let's use blue. To distinguish our labels from the given label. So we have J corresponds to T, angle T. Why? Because they have the same or equal angles or congruent angles. Because they have the same label, the same markings, okay? And also the angle U is congruent to angle K. Why? Because they have the same markings or labels. So therefore, there are two corresponding angles of the two triangles to be congruent. So we have angle, right? Okay, so we can use either the angle corollary or the angle similarity theorem. However, since there are only two angles given, we can use angle corollary directly. But we can also use angle similarity theorem if you want. Okay, by identifying the or by showing that angle B is congruent to angle L by angle sum theorem of a triangle. Okay, but we can use the AAA directly. This is shorter. So therefore, these two triangles are similar. So this is correct. And let's identify the similarity statement. Triangle JKL is similar to triangle. Okay, angle J corresponds to angle T because they are congruent. Angle T and angle K corresponds to angle U, and of course, none other than, oh, what's that? TUV. Sorry, TUV. All right, so triangle JKL is similar to triangle TUV. Okay, so these two triangles are similar. That's so simple, right? Okay, next. Oh, number 5. Now let's identify if these two triangles are similar or not. So again, there are two angles labeled here and there is only one here. So 1, 2, 3. Oh, there are no angles congruent based on the markings or the labels. However, we can say that these two angles are congruent because they are vertical, right? So we can use the AAA or the AA. Let's verify which one is more appropriate, okay, to use to show that these two triangles are congruent. Now we have already one A, okay, one pair of A's to be congruent. So let's use red. Okay, we have one A, okay. And if we're going to observe angle B doesn't have a congruent angle on the other triangle. So therefore, we cannot use this. How about angle C? Angle C doesn't have markings or labels, so we cannot say that it's congruent to angle U or angle T. Again, for using angle similarity theorem or angle corollary, angles should be congruent. They're not supposed to be proportional, okay? Proportionality is only for the sides, not for the angles. Again, for the angles, they must be congruent. So here, there are no other angles to be congruent. Therefore, we cannot say that it is these two triangles are similar by AA corollary or even the AAA similarity theorem because there are only two corresponding, okay, angles which are congruent. So there's only one A, and there is no uh, A angle corollary or angle similarity theorem in our discussion to prove that these two triangles are congruent. So therefore, these two triangles are not similar. All right. So we cannot make any similar statement since these two triangles are not similar. Okay, so let's proceed to number 6. Again, pause the video if you want to answer and check if we have the same answer for us to identify if you already understood how to verify if two triangles are uh, similar or not. So here we go. So let's deal with number 6. Here we have sides 1, 2, 1, 2. So there are two sides given. So it's either we could use the SS or the SAS, right? Two sides, because there are two sides, there are two sides. And also, these sides don't have measures or labels or markings. Therefore, we cannot use the SSS similarity theorem anymore. So our best candidate is SAS, okay? So we need to look for corresponding angles to be congruent. Oh, they're sharing angle K. So therefore, angle K is congruent to angle K, reflexive property, right? Identity. So they're always congruent, whatever happens to the value of K. Okay, so we have already angle. And now let's identify the corresponding parts and let's show that these parts are proportional or their ratios are equal. Okay, so we have the 88, the longest, and we need to find the longest side here, and the shorter, and the shorter. Okay, so eto. So let's do the ratio. So that's 16 over 25, and here it's 88 over, okay, the whole part. Here, the whole part is km, all right, but we don't have value of km yet, so let's identify. So that's 25 plus 107, that's 132, correct? 132, correct. So 132. And we have already identified the ratios. Now let's identify if these two ratios are equal, okay? And let's check. Let's simplify. 16 over 25, it's already in simplest form. How about this? Now by 4. Okay. By 4, yeah. By 4, this is equal to 22 over, this is 43, correct? If I'm not mistaken, 132 divided by 4, 3, 12, 12. Okay, 44. 43. Sorry, it's 33. We're dividing it by 4. Yeah. Oh, sorry. So let me erase it. Oh. It was erased. Okay, sorry. Let me repeat that. Sorry. So that's 16 over 25 and 88 over, what's that, 132. So it's already simplified. And again, this is divisible by 4, so 22 over, that's 33. Okay, oh my God. Okay. 22 over 33. And we can still simplify this. This is equal to, by 11, 2 over 3. And this is 16 over 25, 4 and 5. So 16 over 25 is not equal to 2/3. So therefore, these two triangles are not proportional. That's why we cannot use the side angle side to show that these two triangles are similar, okay? And there are no other theorems or corollaries we can use to show that these are similar, because for AAA, there's only one angle that we identified to be congruent, because these two sides were not given as parallel, so we cannot assume that they are parallel. So therefore, AA cannot be used. And if AA cannot be used, therefore, AAA can never be used as well in this problem. And also the SSS. SSS, we already identified that the two sides are two corresponding sides. Okay, I mean the two pairs of corresponding sides are not proportional. So uh, therefore these two triangles are not similar. Okay, all right. So we cannot use any. Okay, any four of them. Okay, here we go. Number 7. So let's state if the given triangles are similar or not. Again, pause the video if you want. So let's analyze. we have three sides given. Here we go. So three sides SSS. And we could also consider SAS. However, there are no angles given, and there are no angles that we can use to show that they're congruent. So we can slash this off. So let's focus on the SSS, okay? So we have, again, let's identify the longest. So we can easily identify the corresponding parts. So 84 is the longest, 30 is the longest. So let's make use of the ratio. 84 over 30. You can use 84 over 30 or 30 over 84. It doesn't really matter. As long as you are consistently doing that way, okay, the larger triangle over the smaller, then you're on the right track. Okay, so next is the shortest over the shortest. Okay, 42 over 15 and the shorter, so 70 over 25. All right, so we have already identified the corresponding parts, and we also express them in terms of ratio. So let's simplify to check if they are proportional or if the ratios are congruent or equal. Sorry. So let's simplify this by what? By 2. Okay, by 2, 24. Oh, by 6. So by 6, this is 1. 24, this is 14. By 6, this is 5. So 5 over 14. How about this one? By 3. So by 3, this is 1, 14, this is 5. Oh, 14 over 5 as well. Oh, I hope this one works too. So by 5, so by 1, 14, and 5. Here we go. So 14 over 5. All of the ratios have a value of 14 over 5. So therefore, we could say that they are proportional. Okay, so therefore, these two triangles are similar by SSS, similarity theorem. Okay, since they're similar, let's identify the similarity statement. And let's change the color of the pen. Okay, let's use green. So here TUV. TU, okay, the other way to do this is this, TU. TU is the, here, the 70. And 70 is the shorter side of the triangle. And here, 25 is the shorter side of the triangle, right? However, we need to check which comes first. Is it the R or the Q? Okay, here we go. So T, here, T, the angle T, and its opposite side is the longest side. So therefore, the longest side here is 30, and the opposite angle is Q. Therefore, this is Q. Oh, I forgot the triangle. Okay, let me erase. Eraser. Okay, let me put it back to green. Green, okay. So again, triangle, and we identified already the Q corresponds to T, and the U's opposite side is 42, which is the shortest, and the shortest here is 15, and its opposite angle is R. So R, and of course, there's no other letter or vertex or angle to be used. We have QRS. So therefore, our similarity statement is triangle TUV is similar to triangle QRS. All right? So I hope we got the same answer. And okay, how many more left here? Okay, so let's deal with number 8. So let's do this fast. Okay, now look at this. These two angles are congruent. However, this angle has no congruent corresponding part on the other triangle. So therefore, we should be using AA or AAA. However, we have only identified one pair of corresponding angles to be congruent. So therefore, these two triangles are automatically not similar. Okay, that's how we do it. Okay, here we go. Next, number 9. Okay, so we have two angles to be congruent. One pair of corresponding angles to be congruent here. And we have also another angles to be congruent here because they're vertical. So therefore, we have already identified two angles, two pairs of angles to be congruent. And we have a corollary which is the AA corollary, to show that the two triangles are congruent. Since the two angles or two pairs of corresponding angles are congruent, therefore it satisfies the angle-angle corollary. Therefore, these two triangles are similar. All right, understood? And let's fill in the blank, okay, by answering the similarity statement. Triangle HGF. So H corresponds to H, of course. And G, because they're vertical. G corresponds to what? 61, 61, that's T. And none other than HTS, okay? So therefore, triangle HGF is similar to triangle HTS. Here we go. Next, number 10. Let's do it quick. Okay, I hope you can still follow. Now here, we have, let's change the color of my pen. Let's use red. Here we go. So, we have identified equal angles. So angle U and angle F. Okay, angle U is congruent to angle F. So we have already identified A. And there are two sides given, and the angle is included, okay, between the two sides. Therefore, we are going to use the SAS. And let's check if the two sides are proportional. Now here, this 9 is shorter than 18, so therefore we need to look for a shorter side as well. So that's 21. So let's make use of ratio. 9 over 21. And the other one is 18 over 42. And let's simplify. Okay, let's simplify by 3. This becomes 3, this becomes 7, therefore 3 over 7. And let's simplify this by 6. This is 3, this is 7. So 3 over 7. So the corresponding parts of the ratio of the corresponding parts of the triangle are congruent, okay? And the ratios are equal. So therefore, using the SAS, now these two triangles are similar. All right? I hope you got my point. So therefore, let's fill in the similarity statement. Triangle FGH is similar to triangle. F corresponds to 76 here, 76 U. Okay, and G corresponds to the opposite side of G is the shorter side. So the shorter side is 9, therefore it's V. V and none other than W. Okay? All right, so therefore the similarity statement is triangle FGH is similar to triangle UVW. And I think this is the last one. Yeah. All right, so in number 11, this one is quite complex triangle. Okay, so here, let's analyze. We have sides here, sides, 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 sides. Here we go. So we have 3 sides, right? 3 sides. And the triangle has a common vertex, F. So we could also use the SAS. Okay, so we need to show that the sides, the corresponding sides are proportional. So in this manner, okay, so 44, 121, or these are the corresponding sides, right? So 44 over 121. And if this is 91, this is what? 52, correct? Okay, if this is 88, this is 56. This is what? This is 32, if I'm not mistaken. Yes, 88. This is 143. Okay, here we go. So we are trying to show that these two triangles are similar. Okay, so 44 over 21. And here, okay, the short over the whole, that's 52 over 143. And the shorter over the whole, that's 32 over 88. All right? So now here, we need to show that these sides, corresponding sides, the ratios are congruent. Okay? And once we identify that they are proportional or the sides are proportional, or the ratios are congruent, then these two triangles are similar. So we have, let's simplify this by 2. So this is 22. Oh, it's not divisible by 2, sorry. So this is 11 by 11. Sorry for that. So that's, oh my God, 11, this is 4, this is 11. So 4 over 11, okay? And how about this? This is 8, 52. Okay, let's try this one. Easy to simplify. This is 16, this is 44 by 4, this is 4, this is 11. Oh, this is 4 over 11. Here we go. All right. The two corresponding sides are already proportional here. So we can use SAS. Okay. So in SAS, they are, okay, they're already similar. However, since the third sides were given, so we need to make sure that the corresponding sides or the ratio of these corresponding sides must also be proportional to the other two corresponding sides, or the ratio should be equal to 4 over 11, or else it won't satisfy the given condition. Okay, so how do we simplify this? So by 4, 52 is divisible by 4, right? All right, so this becomes what? However, this is not divisible by 4. Okay, here we go. If this is by 4, this is 13, correct? So this is 4 by 13. Is this divisible by 13? Yes. So 13, 1, 13, 1, 11. So 4 over 11. Here we go. So therefore, the ratios of the three corresponding sides are equal. So we can say that it is similar by SSS or SAS. However, I would go to SSS since the three sides were already given, okay? Because there are times that it's similar through or by the virtue of SAS. However, this third, okay, corresponding sides will not suffice the given condition that the ratios of the corresponding sides are proportional. So what if this is not equal to 4 over 11? Therefore, they're not anymore similar. That's why we need to verify that with the use of SSS since all the sides were given, okay? So we already answered 11, and therefore these triangles are not similar, okay? And I hope you understood. Okay, here we go. So we're done, and I hope you learned a lot.